Okay, welcome back. Now we're going to work on our model of seasons. If you take your protractor, go up to here and then go one line down from the diagram we did before. And if you can, if you see 0 and 180 right here, mark these 180 and 0. And then there's a hole in the middle of your protractor, put a line there. And then go up and mark 90 degrees. So we've got 1, 2, 3, 4 marks. And then use the protractor to draw an arc, a half circle, around both. Then we're going to take our protractor, flip it, and use it like a ruler, and we're going to draw a line to split the circle in half. Okay, then we're going to keep it upside down and line it up on the center point on 0 and 180, but it's flipped upside down. And again, we're going to mark 90 degrees at the very top, and then we're going to draw another arc like this to complete the circle. And we're going to go through here, use our ruler like a protractor. We're going to draw a line from top to bottom. Okay, so now we have a circle split in 4 parts. And now we're going to, here's our Earth. So let's say here's our Earth right here. We've got the axis right here, but we need to add a tilt to it so it's like this. Let's make the Earth tilt. So if we go back, line up our protractor, and the Earth tilts 23.5 degrees. So here we've got 90, 100. How many degrees are here? If we go from here, it would be 20 at 110. Then we would go 1, 2, 3.5. And you'd have 113 degrees on your protractor, but really that is a 23.5 degree angle right there. So let's highlight that in blue. It's just a little easier to keep track of these angles because seasons are all about angles. And let's go to the bottom. Just flip your protractor upside down again. And we have 90 right here. Again, we need to go to 113, so we find 110, we go 1, 2, 3, and we have 113.5 degrees. And this angle here is 23.5 degrees again. So we'll mark that in blue, and then we'll use our protractor like a ruler again and draw a line connecting our new tilted axis. Okay, so, and let's label this. This is the axis of the Earth. Okay, tilted. All right, next step. We are going to, and again, just to be clear, this is a 90-degree angle right here. If we go from here to here, that's 90 degrees. Now we're going to measure a few more 23-degree angles. So over here, line up our protractor again. Here's 10, 20, and let's go to 23.5 right here. So again, we have 23.5 degrees. And over here, we're going to turn our protractor upside down again. And do the same thing. We've got 0, 10, 20, 1, 2, 3, 23 degrees again. And we're going to use our ruler, protractor like a ruler again. We're going to connect these two measurements. Okay, now after doing that, we have just laid out the equator. Now this is the midpoint between the North Pole and the South Pole. This is also, another term is parallel of latitude. Latitude is something we'll learn more about as we draw others, but this is how the equator helps scientists measure how north or south of you are of the equator. And one thing about the equator here is that the sun is directly overhead in the equinoxes. And that would be the spring equinox is March 21st, and the fall equinox is September 21st. So at this point, these points, the sun is directly over the equator, but it's not always over the equator. Okay, so we're gonna line up our protractor again. We're on 0, we're on 180. We're gonna go 10, 20, we're gonna go 1, 2, 3. We're gonna measure 23.5 degrees again. And once we have that marked, we're gonna go to our original 90-degree mark right here. We're gonna use our protractor to draw a line from here to here. Now this line right here is a parallel of latitude. This is called the Tropic of Cancer. Okay, and this is 23.4 degrees north. So navigators, astronomers, they'll use latitude to figure out where things are on Earth. And again, the equator would be 0 degrees. That's the starting point. And something about the Tropic of Cancer, the sun is overhead directly on June 21st. So it would be at 90 degrees on June 21st, and this is the summer solstice. And this is the day when we get the most amount of sunlight in the northern hemisphere. So right up here, we've got the northern hemisphere. And again, that is our summer, most amount of daylight. So here's the Tropic of Cancer. Next measurement we're going to do, I'm going to turn our protractor upside down again. We're going to put on the equator. We're going to line up 180 and 0 on the equator. And we're going to measure 23 degrees again. 20, 1, 2, 3, 23.5. So we've measured 23.5 degrees. And now we can draw another parallel of latitude. Now we're going south of the equator. Okay, this new one is the Tropic of Capricorn. And this is 23.4 degrees south of the equator. And they're opposite. This would be South America, Australia. And here the sun is directly overhead. We don't have to write it out again. Their summer solstice, or their longest day of the year, would be December 21st. Now, December 21st is our winter solstice, our shortest day of the year, but it's the opposite if you lived in the southern hemisphere. So that you have equator, Tropic of Cancer, Tropic of Capricorn. We're seeing how the Earth is split up by these angles, and these angles create differences in our seasons. Okay, the last one, we're going to take our protractor again, line it up on the equator, and we're going to find, here's 180, here's 0. We've got 0 on the North Pole. Oops, I'm sorry, 90. And let's label this North Pole. Now let's find on this between 180 and 90, let's find 113 degrees. So here's 110 right here. There's 100, 110. Let's count 1, 2, 3. Actually 113.5 degrees. Okay. Now, what is the point of that? Well, this difference here is 66.5 degrees. And 66.5 degrees is right here. So if you can see, that's not quite a 90-degree angle, it's 66.5. And where would this angle be? So this angle is going from here to here. This is the 66.5 degree angle. And what is that going to tell us? Well, if we go back, turn our protractor around, we line up on this point and on this point here, draw a line. Now we have the Arctic Circle. This is up Canada, Alaska, North Pole, and this is 66.5 degrees north of the equator. That's the parallel of the Arctic Circle. Okay, and finally, if we go down below, we line up our protractor again on the equator. We've got 180. Let's find 113 again. So if we go to 100, we go to 110, count 1, 2, 3. We have 113, actually 113.5 degrees. And that is 66.5 degrees. And then if we use our protractor again like a ruler, now we have the South Pole. Let's label this South Pole. And this would be the Antarctic Circle. And this is 66.5 degrees south of the equator. All right, and the sunlight hits all these places differently, making our seasons different. Different temperatures, different plants have evolved to grow and go dormant. Animals have evolved to it. So here is our Earth. And one last measurement we're going to do. Let's take put it on and let's see if you can pause the video and find our latitude where we live here in Beaverton, Oregon. Okay, what did you come up with? Well, in Beaverton, if we go, here's 0, here's 90. Look for 45. Here's 40, here's 50, 45. Let's put this 45 degrees right here. And let's make a mark at the 45th parallel. You can add a special color to that if you want. You don't have to, but at 45 degrees, that's right about where we live. So you can see on the Earth, we're pretty far north relative to everything else. Okay, pause the video and we'll finish up.